Math 3, Unit 9, Section 0. Okay, this unit we're going to be dealing a lot with area, volume, ratio, surface area. From Math 2, you should have all of these memorized. If you don't, you need to have them memorized. Okay, so area of a circle, pi r squared. R stands for radius. And so we know that in a circle that this is your radius. Okay, circumference is 2 pi r. So again, your radius is your r, which is half of the diameter. Area of a triangle. If you have and you should know this too, but most of you know a rectangle or square. What's the area for a rectangle or square? A rectangle or square is base times height. Okay, I'm making a little side note here. This is called a rectangle. Okay. How do you find the area of a rectangle? No. Base times height. So a rectangle's area is base times height. Now, if you were to take a rectangle and you cut it in half, you get 2 triangles. This is why a triangle is half of the base times the height. Okay, because a triangle is really half of a square. Okay, and a triangle, this is your base, and then your height is the highest point through the center there. Okay, trapezoid. In a trapezoid, you'll notice that there's 2 bases. It doesn't matter which one you label. We're going to call this one base 1, and at the bottom I'm going to call that base 2. When you're taking the area, a trapezoid is like a rectangle, but you have to take the average of the 2 bases. So that's why you're going base 1 plus base 2 divided by 2. So you're taking the average of the 2 bases, and then you're multiplying it by the height. And again, your height would be that up and down. Perimeter is adding up all the sides. So no matter what the figure is, you're going to add up all the sides. The only difference is that in a circle, the perimeter is called the circumference. But again, that's adding up the outside of the circle. Okay? Going down here now to like our volumes and surface areas for our 3-dimensional figures. Yay. We have a prism. Now there are lots of different kinds of prisms. A prism can be made out of any shape. You can have a trapezoidal prism. You can have a triangular prism. You can have a rectangular prism. Yeah, pretty crazy, huh? Anyways, so, but your volume is always the base area. So you always have to find the area of whatever the base is times the height, okay? And that gives you your volume for your prism. The prism and the cylinder really go together. So I'm just going to put and the cylinder, because when you end up getting these formulas on your test, they're going to put them together. And if you look at the cylinder, again, this volume is also the area of the base times the height. The difference is that on a cylinder, your base is a circle. And so if you notice here, you have the area of a circle, pi r squared, times the height. Okay? But really, these 2 are the same formulas. Okay? Your surface area, I want you to basically cross this one out. And same thing with this one, the surface area, I want you to cross this one out. There's no reason to memorize formulas for surface area. Your surface area is always just adding up all the different sides, adding up all the faces. It's the area of whatever you can touch. Does that make sense? Okay. And pyramid, same thing. Surface area is going to be, we're going to cross these out.
What does LA stand for?
It stands for lateral area, but we're going to go ahead and cross those out. So again, surface area is just adding or add up all the faces. I have a video that I'm going to show you guys about why a pyramid has this 1/3 in front. And again, you'll notice that pyramids and cones go together. Basically, the volume of a cone and a pyramid is 1/3 of a prism and 1/3 of a cylinder. And I have a 2-minute video that I'll show you later today, but it's not going to be in the notes. Okay, and so you'll have this formula, 1/3 area of the base. So this pyramid has a base of a rectangle or square. So you do base times height, and then you'd multiply it like for the base, and then you'd have to do your up and down height. And so in a pyramid, that height is that up and down right there, where it's going to touch the center or the vertex of the pyramid and going down. That is the height that you're multiplying by here. Okay? And we're going to go through and do some examples on all these. And then same thing with the cone. The cone, though, when you're finding the surface area, you actually need this formula, and this formula will be given to you. Slant height, this right here is your slant height. And you'll often see that as like, it looks like a cursive L, is how they label slant height.
Oh, yeah.
Okay. And so in order to find your surface area, you would find your lateral area by going pi r times your slant height. Okay. And then base area. So the base of a cone is a circle. So you would do pi r squared here, and then your pi r. So if we want to label this, this would be pi r L for your slant height plus, and this is pi r squared for your base area. And then you have the volume of the sphere. And so just to give you an idea of what I'm going to end up giving you guys on the test is you are going to have this formula sheet. I'll be printing it off for you guys. And so, you know, I have prism and cylinder together on here, and we know that it's the area of the base times the height. So cylinder has a base of a circle times the height for the volume, base of a square times the height. Okay, and when you're doing surface area, you'd find the area of each of the pieces and add them all together. Okay, and so this is, and you'll see here that we have the pyramid is adding up all the faces, but the cone you have to do base area plus lateral area, and then I even give you the formula for lateral area. Okay, are there any questions about any of this so far? Okay, so we just have to remember these so that you know how to find your base areas, and then from there you can find all your volumes and other things. Okay, so we're going to turn over and do some examples now, but you might have to flip back and forth for some of this. Okay, the first thing we're going to talk about is ratios. And so ratios are comparing two things. Ratios are normally, they have that colon in between them, but you can also write ratios as fractions. Whenever you're writing ratios, though, you should write them in simplified form. So 20 and 4, could you reduce that at all? Yeah, we could reduce by what? By 4. And so all we're going to do is divide each side by 4, and we end up with 5 to 1. So the ratio for that example is 5 to 1. Okay, then you have this next one. They have happy faces to circles. Pay attention to what they're telling you should be first and second, because you want to keep it in that order. Okay, and so how many happy faces are there? 4. And how many triangles? 2. And can that be reduced? By 2, and so we divide by 2 to both of these, and we end up with a ratio of 2 to 1. Okay. Perimeter of the large rectangle to the perimeter of a small rectangle. How do we find the perimeter?
Add up all sides.
Add up all the sides. Very good. And so even though these aren't labeled, this other side is a 7, and this one is an 11. And we add all those up together, and what is the perimeter?
36.
Good. Okay, and then on the smaller shape, we add up all the sides, and that equals what? Good. And so if we're doing our ratio, it says to write the ratio from the large rectangle to the small, and so we'd write that as?
36 to 16.
Good, 36 to 16. Can we reduce that?
Yes.
By what?
4.
Okay, if we reduce it by 4, we get?
9 to 4.
Good, 9 to 4. And if you could reduce further, you would, but you can't, and so that is it.
That makes ratios so much simpler.
Good. All right, next one's finding the area of the figures. So what is the formula for finding the area of a circle? Good, so area equals pi r squared. So we're going to go pi, and in this case, my radius is 3, so we have 3 squared. And so we get, my answer is going to be what? 9 pi. Now, and I actually forgot to do this. Oh no, we are okay. You always want to label this. Do you notice how this doesn't give me any units here? So area is units squared, and so we're just going to write units squared. So if they forget to give us the units, we're just going to say, well, whatever the units are, it should be squared. Okay? Do you guys remember how to find the area of a trapezoid?
Base 1 plus base 2 divided by 2 and multiplied by height.
Good. So I'm going to go ahead and write that out. So area of a trapezoid, I'm going to do B1 for base 1 plus B2 for base 2 divided by 2, and then it's multiplied by the height. And so in this case, my base 1 is 6 plus 10 divided by 2 times my height, which is 3. 6 plus 10 is? So we have 16 divided by 2, which is? 8. And 8 times 3 is?
24.
And we'd write that as 24 what?
Units squared.
Good. Okay, questions so far?
Wait, so area has all its unit squares?
Yes. And the reason is because you're multiplying 2 dimensions. So this is a 2-dimensional figure. And so I'm multiplying a height, which would be in units, by a base, which is in units. Because we're not doing 2 bases, we're actually multiplying the average. Does that make sense? And so units times units makes units squared. Okay? And so like perimeter, for these, if we wanted to go back just to label them, the perimeter would have just been units. This is, perimeter is just 1-dimensional. Okay? Okay. All right. Surface area and volume. They want us to find the surface area of each of these and the volume of each of these. Understanding how to find these is important, and it's going to be building. We're going to be doing more of this throughout the chapter. Okay? So let's start with our surface area. So the surface area is adding all of the faces. Okay? So looking at the cylinder, how many faces are there? Okay, so the top and the bottom. So I'm just going to roll up this piece of paper. Okay? So this, it has one circle here. Do we agree? And then one circle here. Yes? Mm-hmm. Okay, so if we find, because we're finding the area. Okay, so the area of a circle is what? Pi r squared, but there's 2 circles, and so for this figure, I'm actually going to have 2 times pi r squared for my circle on the top and my circle on the bottom. Make sense? Okay, so I'm going to go ahead and simplify this right here. So 2 times pi, and then radius is 3 squared.
It's 9.
Good, and so we end up with what?
18.
18 pi, and we're just going to leave everything in terms of pi, okay? Plus, now we have the outside part. So I'm going to show you. So see how we have this piece of paper and we roll it up and we have a cylinder? When I unroll it, what does it become?
Flat.
It's a rectangle, okay? Now, I want you to think, though, the edge. So when you're unrolling this, the edge actually represents what?
The height.
In terms of like a formula, your edge, so right now, the edge of this is a what?
Circle.
It's a circle. So when you're finding what the outside of a circle is, what's that called? The circumference. And so that means we're doing the circumference times the height. Okay? The height is what? 5. Okay? And so what we're going to do the circumference, which would be 2 pi r times the height, is going to give us the area of the middle part of the cylinder. Okay? Because that's really the circumference times the height. And so we'd have plus, and 2 pi r is 3, and h is 5. Is everybody okay with those numbers? Anybody confused? Okay, so we multiply that together, and you get what?
30 pi.
Good. So plus 30 pi, and we add that together, and we get 48 pi, and that will be inches squared because we're dealing with area, and area is always inches squared, okay, or dimensions squared. Okay, so we have our surface area for the cylinder. Now we're going to find our volume. And you can go back and look at your formula if you want to, but the volume of a cylinder is the base area times the height. So in this case, my base area, my base is a what? It's a circle. Okay? So we're going to find the area of the base. So that would be pi r squared times h. And so all we're going to do is plug in our numbers now. So we have pi, my radius is 3 squared times 5. And so we end up getting 9 times 5, which is, good, 45 pi. Now with volume, you're multiplying 3 of the dimensions. You're multiplying the inches twice for the radius, so you have inches times inches, and your height is another inch. So whenever you're finding volume, it's inches cubed, or units cubed, whatever it happens to be. Do you guys need this larger in the back? No? Okay. All right, so we're done with the cylinder. We found both of those values. Are we good? Questions before I move on? No? Okay, so now we're going to go to our rectangular prism. And I'm just going to kind of draw a line here. So we're going to start with surface area. And so how many surfaces, how many faces does this one have? 6. But like 2 of them match, 2 of them match, 2 of them match. Do you guys agree? So if we're starting with our base, our bottom dimensions are 10 by 5. Do you guys agree? And then how many of those are there? 2. So I'm going to go 2 times 10 times 5. And I like to write this out so I can visually kind of see what's going on before I multiply the numbers. Okay? So now I'm going to go to this side rectangle over here. And how many of these rectangles are there?
Is it, did you write 10.5 or 10 times?
That's 10 times 5. There's 2 of these. There's this one here and this one here. Okay? And so this one, there's 2 sides, and it's 5 times 2 for your base times your height. Okay, and we know there's a total of 6 sides. So I have one more side, and there's going to be 2 of them. And this is like my front one right here. And see how this one, the base is 10, but this height is 2. So we have 10 times 2. So you want to make sure you get all of your faces. Okay, and in this case we do. And so now we're going to multiply and add. Are there questions before we multiply and add? Okay, so 10 times 5 is 50, times 2 is 100, 5 times 2 is 10, times 2 is 20, and then 10 times 2 is 20, times 2 is 40. And so we add all those up, and we get 160, and that is centimeters squared, because area is always squared. Okay, volume. So volume for a prism is always your base area times the height. And so this base area is what? 10 times 5. Good. So I'm going to write this out as 10 times 5 for my base area. And then my height of the figure would be 2. And so my volume, 10 times 5 is 50, and 50 times 2 is 100, and this would be centimeters cubed. Very good. Questions? All right, this last one is the one that's a little bit more complex, but I think you guys will be okay. Okay, so we have a pyramid. Now, most pyramids look like this, but some pyramids could have different bases, okay? So remember that you always, for a lot of these, we have to make sure we understand what the base is. So our surface area for a pyramid, we are just going to be adding up all of our faces, okay? So starting, we only have one base. Do you guys agree?
Yes.
And so how do I find the area of that base? Okay, and I'm going to write here base real quick so we understand what we're doing. And the base area, or base area, get this out. My base area would be 12 times 12. Are we okay with that? Okay, plus. Now, along the sides, we have what? We have the faces, and what are those faces? What shape? Triangles. And how many triangles do we have? 4. And would they all be the same size?
Yes.
Yes, and I know they're all the same size because since this is 12, all these triangles have the same base of 12. Now, if this was 12 by 4, you would have 2 triangles that are the same and then another 2 triangles that are the same. Does that make sense? But in this case, we're going to go plus 4 triangles or triangle areas. Are we good with that? Because there's 4 triangles that are exactly the same. So we have plus 4. Now for my triangles, the base is what? 12 times the height. Now this is the height on the triangle because we're looking at the triangle like this, okay? And so when we're doing our surface area, my base is 12. Did they tell me what this height is? No, they didn't. Now, if you're looking at this triangle, I need that area, that length right there, okay? They told me that this up and down one is 10. They told me that this bottom, do you know how much the bottom of this triangle is?
6.
How much is it? Good, 6. Could I find out what that slant is?
Yeah.
What would I have to use?
Pythagorean.
That Pythagorean theorem. Good job. Okay, a squared plus b squared equals c squared. And c is always the diagonal or the long one. So this is my c, okay? And so that means we're going to have 10 squared plus 6 squared equals c squared. 10 squared is
100.
plus,
36
good,
equals 136.
good, equals c squared. So 136 equals c squared. Now we could change this into a decimal, but we're not going to, okay? So we're going to simplify the square root of 36. What does 36 break down to?
136.
What does 136 break down to?
Thanks.
Okay. I'm going to, 2 and something is correct.
But you know, it's
Let's
not.
do a big
It's not. It's not 130. It's not just 36, right? It's 136.
It's 136, right. So it's actually 4 and 34. Okay? Now 34 I could break down to 2 and 17, but that's not going to give me a pair. 4 gives me a pair, right? And so 2 and 2, good. And so this slant is going to be actually equal to what? 2 root 34 is correct. And so right here I'm going to put an arrow and I'm going to say that is 2 root 34. It took a little bit of work. You guys will survive. That was the hardest thing we had to do today. Okay. All right, so for the triangle area, our base is 12 times our height, which is 2 root 34, but then we still have to divide that by 2, right? Because a triangle is base times height divided by 2, but I have 4 of them. Could I just reduce the 2 to any of those numbers there? Yeah, except for the 1 and the root. Okay, so this 2 could go into 4, it could go into 12, or go into 2. You only go into one of them though, okay? I'm just going to cancel out these 2's because that's the easiest to me. So when I go to simplify this, 12 times 12 is 144 plus, and then 4 times 12 is 48, and then you just have root 34. So remember that outside numbers that are not in roots get multiplied together, and if you had 2 numbers that were in roots, you'd multiply the roots together, but there's only the 1 root, so it just kind of tacks onto the number. Okay? And then this will be centimeters squared, because area is always squared.
That's the answer?
Mm-hmm. And we could change this to a decimal, but this is actually more accurate, and so we're just going to leave it like that. Okay, volume of a pyramid. Okay? If you go back to your formula, and this one is given to you as well, it is 1/3 base area, and we're going to end up calling base area, it'll be labeled as like a big B, stands for base area, but I'm writing it out in your notes. So 1/3 base area times height. And so in this case, we're going to have 1/3. My base area, I already found it. Do you guys know what that is?
12 times 12.
Yeah, so you can either write 12 times 12 or 144. Okay, for the notes, I'm going to go ahead and just write 12 times 12. But when you're doing your homework and stuff, if you already found the base area, just put that in, okay? And then times the height. Now, what's the height on this one? 10. Good. Also on this one, do you see how, okay, so when you have a fraction, this 3, you could divide that into 12 and reduce it that way. Or you could multiply all of them and then divide by 3. I like to just reduce if I can at the beginning, so it's less work for me later. And then I have 4 times 12, which is 48, and 48 times 10 is 480. So I'm able to do a lot of it in my head. And it's centimeters cubed. That's correct. Okay, do we have any questions?